In this video I'm going to tell you that the best telescope for astrophotography doesn't exist. What I will do, however, is answer some of the most frequently asked questions I got from you guys about different kinds of telescopes to get into astrophotography. I'll also share my personal experiences and pictures I took with different telescopes over the past years, so you know what to expect. And I'll discuss some good quality telescopes you can buy right now. I hope this video is especially useful for folks who are thinking about getting into astrophotography with a telescope. Let's go! So what is a telescope and how does it work? Well, there are basically two types of telescopes: refracting and reflecting telescopes. Refracting telescopes, like this telescope, has a lens at the front and a tube here to enlarge the object you're looking at or photographing, and also an eyepiece or a camera at the rear where the telescope actually comes into focus. So reflecting telescope, like this one, have a curved mirror at the base of the telescope instead of a lens. Light falls onto the primary mirror at the base of the telescope, and the primary mirror actually reflects that light onto a secondary mirror here in the front, which reflects the light again onto an eyepiece or a camera, as you can see here, for visual observations or astrophotography. Now, there are lots of different types of refracting and reflecting telescopes, so let's reflect on that some more. That is a lame joke. So let's start by taking a look at refracting telescopes, which were originally invented by the Dutch, which is maybe also why they are so expensive. Now, most commercial refracting telescopes nowadays, they have at least two lenses and are referred to as achromatic telescopes, or achromats in short. Now, achromatic telescopes are able to bring 2 out of 3 wavelengths, usually the red and the blue light, into focus. Now, as such, they are great for visual astronomy, but not so great for astrophotography, as they suffer from color aberrations because the green light is out of focus. Just look at this picture I took with this achromat telescope of the Horsehead Nebula. Now, you clearly see all kinds of color imperfections, not to mention the strange shape of some stars. I can't believe I'm showing you this picture actually. Not exactly the kind of picture you want to share. So let's move on. So apochromatic telescopes like this one, they are also called triplets because they have 3 lens elements at the front of the telescope to bring all 3 wavelengths of red, green and blue light into focus. Now, apochromatic telescopes are therefore excellent telescopes to take high quality astrophotography pictures. Just take a look at this picture of the Horsehead Nebula I took with this apochromatic telescope, and you can easily tell the difference. That's more like it, right? Apochromatic telescopes, they can still produce elongated or out of focus stars towards the edge of your field of view. You can buy an extra field flattener with an apochromatic refractor to get pinpoint stars all the way towards the edges of your astrophotography picture. Now, there are also refracting telescopes with a built-in field flattener. These are called quadruplet telescopes. Now, besides the number of lenses, refracting telescopes also differ in other areas, such as the quality of the glass used. Now, one famous example is a high-quality FPL 53 O'Hare glass. O'Hare? Isn't that also a shoe brand? Anyway, other things to look at are also the diameter of the lens, which is referred to as the aperture, and the length of the tube, which is referred to as the focal length. The bigger your aperture is, the more light you can collect, and the longer your focal length is, the more you can magnify the objects you want to image in the night sky. Now, there are many different types of reflecting or mirror-based telescopes. Let me give you a quick rundown of the most important designs, which are Newtonian, Dobsonian, Ritchie-Chrétien, Schmidt-Cassegrain and Maksutov reflecting telescopes. So the Newtonian telescope was actually invented by Sir Isaac Newton. So Newtonian telescopes have an open tube design with a primary mirror at the base of the telescope and a secondary mirror in front of the telescopes, which is held together by spider vanes. The secondary mirror reflects the light at a 90-degree angle to the side of the tube onto an eyepiece or a camera. Now, Dobsonian telescopes have a similar design to Newtonian telescopes, but often come with an additional manual altitude azimuth mount to aim at objects in the night sky. Now, all Newtonian telescopes do suffer from so-called off-axis coma, which means that stars towards the edge of your field of view will appear to be elongated and out of focus when taking pictures of the night sky. You can buy an additional coma corrector with a Newtonian telescope to resolve this issue. Both telescopes need to be collimated, which refers to the process of aligning the two mirrors to bring the light into focus. So Ritchey-Crichet telescopes, or RCs in short, they are a lot like Newtonian telescopes. They also have an open tube design with two mirrors. However, there are also some differences between an RC and a Newtonian telescope. For instance, the RC comes with two hyperbolic primary and secondary mirrors. RCs also have a so-called Cassegrain design, where the ultimate image is formed behind the telescope instead of at the side of the tube. Now, the main benefit of RCs is that they do not suffer from off-axis coma, so they can produce pinpoint in-focus stars across the entire field of view. So you don't need an additional coma corrector. Now, the main challenge with many consumer RCs, in my opinion at least, are that they are pretty difficult to collimate. The final two designs I want to mention are so-called catadioptric telescopes. Now, these telescopes use both mirrors and lenses to produce images of objects in the night sky. Now, the most often used catadioptric design is a Schmidt-Cassegrain telescope, or an SCT in short. Now, in an SCT design, the incoming light passes through the Schmidt corrector lens, also called the corrector plate, at the front of the telescope, which is slightly curved. Now, the incoming light is reflected from the primary mirror at the back of the telescope to the front of the telescope again, where it is reflected again by a smaller secondary mirror that is positioned behind the corrector plate. Now, finally, the light travels back through a hole in the primary mirror at the rear of the telescope, where an eyepiece is located for visual observation or a camera for astrophotography. Now, Maxitov telescopes, they have a similar design, but instead of a Schmidt corrector plate, they use a Maxitov corrector plate. Now, also Maxitov telescopes usually have a somewhat shorter aperture and a longer focal length as compared to SCTs, which is ideal for planetary observing and imaging. Now, normal consumer-made SCTs, they do suffer from off-axis coma, but there are advanced SCT designs like the Edge HD telescope from Celestron and the advanced coma-free telescopes from Meade, where off-axis coma is reduced to a minimum. And that makes those telescopes suited for planetary as well as deep sky astrophotography. So, what is the best telescope for astrophotography? Well, many folks have asked me that question, but the answer is not so straightforward. So let's take a step back and first talk about the objects we actually want to photograph in the night sky. Now, these objects differ in brightness and in size, which has consequences for the type of telescope you might want to consider when getting in astrophotography. Now, I'll show some examples of pictures I took from the same objects in space using the two telescopes I just showed you to emphasize my point as we go. Now, let's discuss the bright but small objects in the sky first. Now, if you want high quality images of the planets, my advice would be to buy a telescope that has at least a focal length of about 2000 mm and an aperture of about 200 mm or 8 inches. Now, to give you an idea, here are some pictures of the planets I've attempted to capture with my Celestron Edge HD 8-inch telescope at a focal length of about 4000 mm using a 2x Barlow lens to increase my focal length. Now, as you can see, the pictures do show some surface details of the planets, but they are still rather small. Now, here's a picture of Jupiter taken with my 480 mm focal length refractor telescope. Not so impressive, right? You can see the cloud bands, but Jupiter appeared as a tiny planet in my field of view of my refractor telescope, even after I was using a 2.5x Barlow lens to increase my focal length from 480 mm to 1200 mm. Now, let's also look at bright and big objects in our night sky. Now, the moon is of course one example, but there are also objects beyond our solar system like the Pleiades, or M45. Now, this is a very bright and sizable open star cluster. And another famous bright and big object is of course the Andromeda Galaxy, our neighboring galaxy. And one final example is the Orion Nebula. This is of course one of the most famous targets in the winter sky. That is, if you can find a gap between the clouds. All of these deep sky targets, or DSOs as we call them, are relatively big and bright. So as a consequence, you don't need a telescope with a long focal length or a large aperture to photograph them. Now, for example, I have captured all of the objects I just mentioned from my light polluted backyard with my apochromatic refractor I just showed you, with an aperture of 18 mm and a focal length of 480 mm. Now, let me also show you this picture I recently took of the Orion Nebula, as well as these pictures of the moon with my Celestron Edge HD 8-inch telescope at a focal length of 1422 mm. Yes, the eagle has landed! You can clearly see that a longer focal length helps to magnify the objects, and a larger aperture helps to get a higher resolution image of objects in space. Now, there are lots of nebulas in our Milky Way that are pretty large, but also a bit dimmer as compared to the bright objects I just mentioned. Now, some famous examples include the Heart Nebula, the Rosette Nebula, and also the Horsehead Nebula I've already showed you. Now, these sizable nebulae, or nebulas, or nebulae, can be captured with a telescope at a modest focal length. Now again, all of the pictures you just saw were captured with my 480 mm focal length apochromatic refractor. But here are also two close-ups of the Horsehead and the Flame Nebula taken with my Edge HD 8-inch telescope at a focal length of 1422 mm. That star Alnitak you see in the picture, it is a little bit on the bright side. Alnitak is slightly brighter than our Sun anyway, about 21,000 times. Finally, we have lots of tiny nebulas and galaxies that appear as relatively tiny and dim objects in the night sky. Now, one example is M51 here, the beautiful Whirlpool galaxy at 25 million light years from Earth. Let me show you another comparison. This is a picture I took with my apochromatic telescope at 480 mm of focal length, and here is the same picture of the Whirlpool galaxy taken with my Celestron Edge HD 8-inch telescope at 1422 mm of focal length. Now you can clearly see the difference in terms of magnification and resolution of the object. Now, here's one last example of the Pac-Man Nebula. Yes, after the video games in the 1980s. Don't shoot the messenger, because I didn't invent these names. Now here are two pictures of the Pac-Man Nebula. One captured with my refractor at 480 mm of focal length, and one with my Edge HD at 1422 mm of focal length. Now again, you can clearly see that the longer focal length and the larger aperture result in a greater magnification and a higher resolution picture of these particular objects in the night sky. I do want to add that tracking objects in the night sky at such high focal lengths is much more difficult than at lower focal lengths, as each small error in tracking will result in a blurry picture. You therefore need a very stable equatorial tracking mount, as I've discussed in other videos on my YouTube channel. So, if you want to know more, then by all means hit that like and subscribe button and join my channel. So in this final part of the video, let me discuss some telescopes that are excellent to get into deep sky astrophotography. I do want to mention I've made a separate video about excellent telescopes for planetary imaging, and I will link to that video in the video description below if you're interested. Now, all of the telescopes I'm going to mention are also linked in the video description below. So let's go! So what are some good quality telescopes for deep sky astrophotography? Now, if you ask me, I've always been a fan of apochromatic refractor telescopes to start your astrophotography hobby. Now, let me tell you why. Now, first of all, it is of course a Dutch invention, and I'm Dutch, so... Okay, I'm sorry. First of all, most apochromatic refractors, they produce high quality images of deep sky objects without any noticeable color aberrations. Also, smaller apochromatic refractors up to 80 mm of aperture, and I'm talking about 600 mm of focal length, those refractors are pretty lightweight and therefore easy to set up and use. Now, another advantage is that refracted telescopes, they do not require any kind of collimation. So That's a big plus, I think, in comparison to reflecting telescopes. Now also the limited focal length on the smaller apochromatic refractor telescopes, they allow for a higher periodic error when tracking objects in the night sky with your beginner telescope mount. Now, some good quality apochromatic refractors on the market in the range of 200 to 400 millimeters of focal length are, in my opinion, the Telescope Service Photoline 6360, the William Optics Zenith Star 61360 and the William Optics Red Cat 51360. Now, if you want a slightly more magnified view of objects in the sky, good apochromatic telescopes in the range of 400 to 600 millimeters are, in my opinion, the Telescope Service 8480 and the Explorer Scientific 8480 millimeter apochromatic telescopes. Now, if you want to go beyond that, one beast of an apochromatic refractor is the Explorer Scientific 127 millimeters aperture and 952 millimeter focal length telescope. Now, one of the main drawbacks, of course, of refracting telescopes is that they increase exponentially in price at higher focal lengths and bigger apertures. Also, they become a bit heavier and more difficult to handle at higher focal lengths. So in my opinion, at about an 8-inch aperture or 200 millimeters aperture range, you should really reflect on buying a reflecting mirror-based telescope over buying a refracting lens-based telescope. Sorry, I couldn't resist. For example, Newtonian telescopes are pretty favorably priced and offer a good aperture and a focal length. Now, some examples are, for instance, the Orion and Omegon 8-inch aperture astrographs with a generous focal length of 800 millimeters, or you could also consider a Ritchey-Chrétien telescope. Now, please do take into account that all reflecting telescopes need to be collimated, which can be especially challenging with a Ritchey-Chrétien telescope or with an f4 ratio Newtonian reflector. Also, most reflecting telescopes, they will show diffraction spikes in your pictures. Now, some people love them, other people hate them. Now, you also need an additional coma corrector with a Newtonian telescope, so take that into account, or a flat field corrector when buying an apochromatic refractor telescope. So one final consideration you may have is to buy an advanced SCT, as I did with the Celestron Edge HD 8-inch telescope. Now, these telescopes may be interesting when you are looking for an all-round telescope to get into planetary imaging as well as astrophotography. So you see, there's not really a straightforward answer to what kind of telescopes are best suited for astrophotography. Sorry about that. If you're still here after all of this, it proves you have good taste. Please like and subscribe to my channel, and as long as you're here, click on one of these other crazy videos about astrophotography. Clear skies!